Okay, let's solve this DE that just doesn't have a 1 in front. It has something a little more interesting out in front. This does not lead to any singular solutions. We don't have to worry about that because 1 plus x squared never equals 0 on the real numbers. We don't have to worry about any singular solutions. Y, just like always, sum from n equals 0 to infinity, a sub n x to the n. Here's y prime, here's y double prime. We've done a bunch of these. Now, notice I've written y double prime a couple of different ways. I could start him at 2 since the first two terms are 0. Then I could, if I wanted to, raise all of these up by 2 while simultaneously dropping my starting point down by 2 to make him go x to the n and start at 0. I'm going to need both versions here, the x squared times y double prime in my x to the n minus 2 times x squared will give me an x to the n. That term will already match this guy. This one, however, the 1 times y double prime, I'm going to be better off using this version. Okay, so I've written all this out here. Here's 1 times this one. I wrote it out like this. X squared times this version. Those mean the same thing. Here's my negative 2x times y prime, and then 5 times y. Okay, and let's look and see what happens at each one of these. X squared times x to the n minus 2 is just x to the n. Negative 2x times x to the n minus 1 will be negative 2 x to the n. X times x to the n minus 1, just add the exponents, x to the n. I brought that 5 in, and now I got to fix this one. This is the only one that will not automatically just pop up an x to the n. But I can raise all of these up by 2. Notice all the n's went up by 2 if I drop this starting point down by 2. Now everybody starts at 0, and all my powers are x to the n. Then I can squeeze everything together into one single sum times x to the n. The only way this sum can equal 0 for every value of x is if every coefficient is 0. So we get this equation in terms of the a's, which gives me this recursive formula. You can check the algebra here yourself. And then I can start plugging in values of n to get my different a's. Always keep in mind the number you're plugging in for n is usually not the a you're finding. If I plug in n equals 0, I'm finding the value of a2, which will be my coefficient of x squared. A7 is the coefficient of x to the 7th. So there are a lot of arithmetic involved here. Then I said, okay, let's make this an initial value problem. So let's solve y of 0 equals 1, y prime of 0 equals 0. Remember, y of 0 is always a0. Y prime of 0 is always a1 for a second order DE. So here is my general solution, or here's my solution to my initial value problem. And I went ahead and graphed this in Microsoft Excel, and then I graphed the actual solution there. So we're looking at that little piece of it there in Excel. And just to see what value I would get using just these first few terms, plugging in a 0.2 there for all of the x's, I get this. And then I didn't bother to find what the actual solution would be there. That's that value right about there. But this is a pretty good approximation.